sideways. Okay, this is an equation that is in equilibrium. How do we know that? The arrows go both ways. And all of these guys are gases. Gases are probably the bulk of the...
What is that next to the H2?
The H2, this is a 3. Badly written. Okay, we're going to do letter A in question number 11 on page 574. And we're going to use Le Chatelier's principle to predict how each of these changes would affect the ammonium system. Yeah, the ammonia equilibrium. Okay, so we're going to put over here what happens to ammonia, the NH3 concentration. Okay? And in number A, the action, yeah, letter A. This is a 3-part question. The letter A, the action is that we're going to remove H2. Okay? Not all of it, but some of it. Now, if we remove hydrogen, what Le Chatelier wants to do is make more hydrogen. Remember, Le Chatelier is the naughty teenager.
What? So she wants to make what? Naughty teenager.
Naughty teenager, yes. Okay, so Le Chatelier sees that we have removed the H2, and he wants to put as much of it back as he possibly can. So, here's what's going to happen. He sees that he has ammonia over here, that this equation is in equilibrium. And he knows that if he rips this thing apart to make these two guys, he can put some of the hydrogen back. So as this comes apart, we're going to get more hydrogen, we're going to get more N2, and this is called a shift to the left. I don't know what's so funny. I'd appreciate it if you would stop it. So, as we take this guy apart, we're making these two. So the action was to remove it. Le Chatelier is putting it back, and that's a shift to the left. And what does that do to the amount of ammonia? Reduces. It reduces the NH3 concentration. That's it? Okay? No math. It's just a real simple thing. But you got to keep your head on straight. These equilibria things will drive you to drink if you don't watch what you're doing. So take them slowly, and this particular thing is working with concentration. It works with other things as well. We're going to do all 3 of them that it works with. Well, okay. Well, let's talk about what would happen if I add ammonia. What's going to happen to the amount of NH3? Okay, and which way would it shift? Towards making ammonia or towards making... To the right. So it would shift to the right. Okay? What if we took ammonia out?
Then you have to take something else.
Okay, how are we going to get more ammonia? Which way do we go? Left or right? To the right. That's how we make it. We put these two things together. Is 2 enough? I'm talking to you. Yes?
Yes, 2 is enough.
Good. Demonstrate that, please. All right. Let's go on to number 12. And in number 12, what we're doing is we're working with pressure. And this is how you solve your pressure problems. The action is vessel gets smaller. What does that do to the amount of pressure? I take a balloon. I squeeze that thing. If I squeeze it hard enough, what happens? It pops. Why? Because I gave it too much pressure by making the thing too small. And the balloon was not able to hold the pressure. Okay, so now what we're going to do is we're going to see what happens. What happens over here. And we're going to look at the shift, and we're going to see what is accomplished. It says, how would decreasing the volume of the reaction vessel affect each of these equilibria? Well, here's the equilibrium. I'm going to have to do it down below it. So we have 2SO2 plus O2. Sure. Is that better? Can you see now? Okay, and these guys are gases. This is your homework, by the way. I'm doing homework problems for you. And we're going back and forth with 2 sulfur dioxides, or trioxides. Okay, so I have taken the vessel, I've squeezed it down to make it smaller, which boosted the pressure. And how are we going to figure out how to decrease the pressure that Le Chatelier can work with? So, when we're talking about pressure, we look at the moles of gas. Remember, there's 22.4 moles of gas at STP is equal to what? Is equal to what? 1 mole, yes? Yeah. 1 mole. Does it matter what the gas is? No. Okay. So, if we know the moles of gas on each side of this equation, we can decide which way to shift it so that we can get more or less gas. So, how many moles do I have on this side? 2 plus 1 is 3. So I have 3 moles on this side. Over here, how many do I have? 2 moles. Okay? So if I have 3 over here and 2 over here, which way do I go to back this out? Vessel gets smaller, pressure goes up. Which way is it going to go to get smaller? Pressure, less pressure. Okay. Left is more moles. Right is fewer moles. You see? Okay, so we're going to shift right to make fewer moles. Got it? Okay, the next problem I'm going to do on a new video, so we'll stop this.